The heading for Lesson 3.8 is Solving Equations and Formulas. You'll learn to solve equations for given variables and use formulas to solve real-world problems. Ron Toomer designed the Magnum XL200. This roller coaster starts with a vertical drop of 195 feet and then ascends a second shorter hill. Suppose when designing this coaster, Mr. Toomer decided he wanted to adjust the height of the second hill so the coaster would have a speed of 49 feet per second when it reached its top. If we ignore friction, the equation g times 195 minus h equals 1/2 v squared can be used to find the height of the second hill. In this equation, g represents the acceleration due to gravity, 32 feet per second squared. H is the height of the second hill, and v is the velocity of the coaster when it reaches the top of the second hill. They gave us g was 32. We're trying to find the height, and they told us the velocity they wanted it to reach was 49. I'm not going to distribute the 32. I think I'm just going to divide both sides by 32. Then I'll have 195 minus h equals, use the calculator. If we subtract 195 from both sides, we get negative h equals negative 157.48. And divide both sides by negative 1. H would be 157.48 feet. Now that I've done a full-blown example of solving with a formula, this is going to look pretty short. They asked us to solve for b. So to solve means to get everything on one side of the equation. So just I want b by itself. So I'm going to subtract 12c from both sides to undo the plus 12c. So I have 5b equals, they're not like terms so I can't combine them, 9 minus 12c. And then I'm going to divide both sides by 5. And I have b equals, those are not multiples of 5, I'm just going to leave it, 9 minus 12c divided by 5. For example 2, they ask us to solve for x, so I'm going to get everything with x on one side of the equation. So I'm going to add, on example 2, they ask us to solve for x, so I'm going to get x on one side of the equation by itself. So I'm going to get rid of the minus 2z, so I'm going to add 2z to both sides of the equation. So now I have 7x equals 4 minus xy plus 2z. They're not like terms, I can't combine them. So now I'm going to add xy to both sides of the equation to get all the x's together. Again, we don't have like terms, so I have 7x plus xy equals 4 plus 2z. Now I'm going to undistribute that x. So I'm taking it out. It's called factoring. But for today, undistribute, it's fine. So now to get x by itself, I'm going to get rid of that multiplying. So I'm going to divide both sides by 7 plus y. So all that I have left is x equals 4 plus 2z divided by 7 plus y. This one might be worth watching a couple times because it's got a lot of steps to it. A car's fuel economy E, miles per gallon, is given by the formula E equals m divided by g, where m is the number of miles driven and g is the number of gallons of fuel used. Solve the formula for m. Wow, that is so much shorter than what we just did. To undo divide by g, all I have to do is multiply by g. So I have m equals GE. And I am done. If Claudia's car has an average fuel consumption of 30 miles per gallon, she used 9.5 gallons, how far did she drive? Okay, this is kind of an odd way of answering or asking a question, but okay. Okay, in the last question we solved for m, so now we can substitute in they said G for gallons was 9.5 and E for economy was 30. So if we multiply 30 times 9.5 or 9.5 times 30, we get 285 miles. A more normal question would be, hey, Claudia drove 295 miles on 9.5 gallons of gas. What's her fuel economy? Dimensional analysis is the process of carrying units throughout a computation. We'll use dimensional analysis on part B of example 4. The formula for the volume of a cylinder is V equals pi r squared h, where r is the radius of the cylinder and h is the height. Solve the formula for h. Okay, so we have V equals pi r squared h. H is being multiplied by pi and r squared. So to undo multiplying, all we have to do is divide. And we're done. We'll rewrite it. H equals V divided by pi r squared. What is the height of a cylindrical swimming pool that has a radius of 12 feet and a volume of 1,810 cubic feet? Okay, so using the formula that we just developed, we'd had V divided by pi r squared equals h. So we know the volume. Okay, the volume they gave us was 1,810 cubic feet. And there's pi again, and the radius they gave us was 12 feet, and it has to be squared. Okay, when I put that in the calculator and divide, I get really close to 4, and feet cubed divided by feet squared would just be feet. And we knew that height should be feet anyway, so the dimensional analysis wasn't super helpful in this one. There's better problems for dimensional analysis than that.